Hello, guys. Welcome to another episode of Cuda Education. Today, I want to what is it? Control plus. Okay, yeah. Today, I want to discuss. I really want to discuss a thing called the Schlick phase function. Schlick phase function is that the is that the way how we say it? The Schlick phase function, and it basically defines how the streaking happens in the fog. Okay, so for those of you that have been rocking with me for a while on the Apple Meadow side, um, we have we basically have an application, an example application that's freely available. This guy, and as part of the application, we have fog. Okay, it's formally called volumetric scattering for those that are academically and intellectually inclined. It's called volumetric scattering. Okay, and what happens is that apparently there is a setting inside of our application where we can basically we could we could mess around with the streaking or the banding of the fog and sort of make it more realistic, less realistic, all of that good stuff. So the purpose of this episode is to investigate playing around with the setting, investigate figuring out what the setting does, and all of that good stuff. Okay, so that's sort of the task for today. But really quickly, before I get to that, I just want to quickly investigate another setting. This is the exponential height fog scale. Okay, and what it is it increases how much fog participates in scattering. Okay, now I'm gonna in another episode probably investigate this some more, but I want to just show this setting because it's kind of easy to show, and it's just another tool in our toolbox that we could use to sort of figure out what's going on here. Okay, so we have the setting here for the exponential height fog scale, and if we change this setting, so right now it's 0.1, if we do 0.9, right, and we run our application, we will see that we get more fog. Okay, and again, this is just how much fog is involved in the scattering. Okay, and as I said, we're gonna have to investigate this some more, but what I really want to show you guys is what happens when we increase this to a very high number. Okay, and this is what we get as a result. Now, the reason why I wanted to bring this up is this is the reason. Notice how scary it is, right? Like we can't even fully orient ourselves in the scene. And we've been looking at this scene for a long time, okay? We've been playing around with this application for a long time. But this, guys, ladies and gentlemen, is the reason why it is so important for us to follow and respect fire code. Because no matter how familiar you think you are with your surroundings, if all of a sudden your surroundings is like this and you literally can't see your hand in front of you, now you get scared. Now you get anxious. Now you start running. And remember, if you start running and you're not paying attention to your steps or your paces or whatever, you effectively have disoriented yourself in the scene. You have effectively disoriented yourself in the room. And this is how a lot of people, you know, visit the afterlife, right? Because everyone is anxious, everyone is frightened, you're running, you disorient yourself, you can't breathe, there's fire, there's smoke, your eyes are probably burning, and, you know, bad things happen. So this is why it's important to follow fire code. Make sure that, you know, if you're building something, you build it to spec, because very bad things can happen if you get smoke and you can't really orient yourself or see where you are. It's bad enough if you are in your own home, or you're in a place that you've lived in for a long time. That's one thing. But if you're in a new venue, you know, like you're at a party or something, or in a new space, and you have no idea where anything is, things get very scary. Now, in our case, we have these windows here that's sort of showing, so we could kind of orient ourselves, and we have this light beam here, right? But this is why people spend a lot of money to make sure there's fire extinguishers, there's a fire code, and time and effort is spent to make sure that, you know, code is followed, and the code is up to spec, and code is updated and maintained, and all that stuff, right? So that's that for our exponential height fog scale. Let me make sure I put things back to where they were. Let's just make sure that we are back to where we were. Okay, right. So we have our scene again. Okay, great. All right, so the next thing, this setting, by the way, is inside of our scattering function. Accumulates the scattering from the sun and local lights plus a temporal reprojection of the scattering data from the previous frame. Okay, we're actually in the AAPL scatter volume .m file. So we're in renderer, shaders, AAPL scatter volume. Okay, and we're in the scattering function, as we could see right here. We're in the scattering function. Okay. That is that. So that's exponential EXP height fog scale. Now, if we do EXP height fog scale. All right, so we use it as part of the scattering coefficient. And you know, that's that. All right, but we want to start messing around with the Schlick phase function. Okay, and that's this guy right here. So right now we are at 0.3, which is the default for the application, and we have this. Now, what's supposed to happen if we go down, if we take out this variable and we run, we sort of get more of, a misty scene. Okay, so we don't get as much banding, and it's a little bit more consistent, I would say. And if we go back to 3, which was the default, we will see that we get somewhat more banding, if you will, but not very obvious. Okay, so then we go to 9, okay, because we really want to see what the difference is. So we see that it's a little bit darker. Um, we get a little bit more, you know, we could say streaking, if you will, but it's not as obvious. Do you guys see anything that's like pretty obvious with this? So let's go back to 0. And I do notice this is darker, and you do kind of have more of a, like if we go here, we do kind of see more of a, I don't know. Okay, so let's go back to 0. And we see that, you know, there's more of a mist. It's more of an average fog, if you will. Yeah, definitely this is more brighter because we have more fog. And I guess the light is more spread evenly. I guess the light reaches farther and is spread evenly. Um, if we go to here, we don't see as much. I don't know. It's very hard for me to describe it, but like I mean, I do see a difference, but it's not like it's not obvious, right? I don't know what that's about over there. Yeah, it's more the fog is more condensed, if you will. Okay, and the lights don't really. What is all this blue? So you see, like the lights don't really project out onto the fog as much, right? Even if we step back a little bit, you know, we go back to 9. We go back to 9. We could see that. Yeah, the lights do project out a little bit more, but yeah, it's more of a discrete sort of fog, and it doesn't spread as much. If we go back to 0 again, yeah, we see the light has more of a reach. But anyway, guys, that's what I wanted to investigate today. But I have a trusty little friend. I have a trusty little friend that is going to help us in our endeavors because we are in 2026, guys. Do you understand what I'm saying? We are in 2026. Times have changed. Times have changed. So say hello to my little friend. Okay? And for all intents and purposes, that little friend is right over here. Okay, so we have questions. So this G value, right, this G value is used, here. But I want to see where so we're using it all over the place, okay? But we're gonna start from $188, okay. So 188 is where we set G. And then we use it for direct light. Yeah, I'm gonna ignore all the places where, you know, it's not using G, because G is how I know I affect the Schlick phase. Okay, so Schlick phase, it's dealt with on the direct light portion. Okay, so our task for today is to investigate. Okay, what is the Schlick phase function and how is it used in our application? So if you guys want to be able to run Codex or Claude in Xcode, follow my I have a previous episode discussing this stuff, and you know, basically the current version of Xcode, it is now readily available on the App Store, allows you to integrate your Codex or Claude into your application like this. The reason why you want it integrated into here is because it's aware of your application, right? So it's not like you're on some website and you got to upload all the files associated with the application. As you can see, this application has many files, right? Many folders with many files in them. Okay, it's you know, so you want something where it's aware of you know, the application in its entirety, and then you could ask it questions and it will give you answers related to what's in front of you. Okay, so you know, Xcode and macOS and all that stuff makes it super easy for you to do this stuff, to integrate your model provider, your model provider into your application program, you know, application creation process. application programming process, right? And that's exactly what I'm doing here. It's literally super simple, right? You just have to make sure you have the latest OS, you have Apple Intelligence turned on your machine. Um, you have whether it be a subscription to one of the services, even though you have a subscription to one of the services, and then you'll be able to basically attach your service to your Xcode project and run with it. Okay, so let us see what it says. Okay, so what is a Schlick phase function? It's an inexpensive phase function approximation used to model anisotropic scattering in participating media. In this file, Schlick phase cosine theta g returns a normalized lobe based on the angle between the light direction and the view direction, with g controlling anisotropy. 0 is isotropic, positive is forward scattering, negative is backward scattering. We didn't try negative, guys. In our app, it shapes volumetric scattering for both the sun and local lights. The code uses g equals 0.3 f, mild forward scattering, and feeds cosine theta, this guy, into the phase. Then multiplies by light color intensity and shattering to accumulate the scattering term. See modern renderer, shaders, APL scattering volume, .metal, line 62 for the function. Okay, let's do that. Right, for the function, and 204 for the sunlight usage. So this is a function right here. Local lights use 87. So we have our function here. This is the function. And then for the sun, we do 204. Control L. So for the function, we do 204. This is for the direct, right? So for our purposes, because I set it here at 188, it does use it here for the direct light. So that's 204. And then local lights is 87. Do I see? Okay, so we use it for at 87 for the local lights. So 87 and 136. Okay, so let us just ask it some more. So give me more details on the phase function. So okay, so the thing though is guys, we can do 188, right? We can do a we can do a negative value. So let's try that. I actually didn't try a negative value. So let's try running a negative value and let's see what happens. So now we're making the fog a lot more misty. It's a lot more. It's prevalent, but it's not in a way that it's like overwhelming the scene, right? It's not overwhelming the scene. So we see that it's not overwhelming the scene. But we do get more fog. So let's increase it and see what happens. Okay. Basically now we are taking away, we're sort of taking away the direction of the beam. Okay, so what I think is happening here is that, so when we do a large negative value, it's sort of the light beam skips the fog, but then we see it on the ground. So it skips the fog. We don't see any fog, but then we do see the light on the ground, right? And same, so when we go back to where we were, is it here where we were? Yeah, what is this thing here? Because when I go over here, I don't see it. But then when I go back here, I see it. What's that about? See, I don't see it. Where is it? It like disappears and then reappears. Yeah, what is that? Let's do 5. Yeah, guys, this requires more investigation. So we're at negative. We're at negative point 1. But if we go to 3 now, we get back to this guy. So let's just do 3. So we're going to do 3. And negative 3. Do you see much of a difference? Actually more misty. Yeah. Anyway, all right. So let's continue with our investigation. Okay, so more detail on the Schlick phase here. It's a lightweight approximation of the Greenstein phase function, which describes how much light is scattered into the view direction based on the angle between light direction and the view direction. All right, so I guess it's taking into account where the camera is. The function in this file with k equals g um that means it's okay, so that means, so this function here, that means it's normalized over the sphere and the shape is controlled by g. Okay, cosine theta, this guy right here, is the cosine of the angle between incoming light and the view ray. Negative sign matches the convention of light traveling toward the point. G controls forward or backward scattering. So G equals 0, isotropic, constant lobe. G greater than 0, positive, forward scattering, bright halo around the light direction. Less than 0, backward scattering. In this shader, it's used as a multiplicative lobe that scales light color intensity during volumetric scattering. So higher forward scattering boosts the perceived God rays fog glow when looking towards lights. Referencing in code, this, and this. Okay. Now there's one thing that I need to I need to tell you guys about as it relates to Codex. Okay, so there's ChatGPT and there's Codex. Codex is the feature of ChatGPT that's dedicated to code. Now the thing is that generally speaking, Codex is known to be very concise. Okay, so if you really want to know about stuff, ideally you want to ask ChatGPT directly. Okay, only problem is if you go to ChatGPT, you're kind of gonna have to like upload files and like let it know which projects you're dealing with and like all of that stuff. It's not inherently it doesn't inherently know your project and all the moving parts of your project. It basically would just reference the file that you uploaded, right? So it's sort of a catch-22 between ChatGPT and Codex. In Codex, you could ask it stuff, but it's gonna be very concise and direct to the point, and that's done on purpose. Okay, so if you really want to learn stuff and really investigate a particular feature, you're gonna have to go to ChatGPT. Again, it means you're gonna have to be uploading files and stuff, and it doesn't fully know the full context of all of the files in your thing. I mean, I've tried giving ChatGPT the full zip file of the project, and it doesn't really work because there's like a limit to the number of files it can read, and it has problems, reading the zip file and all of that, right? So, that's sort of the thing. Now, the thing about it is that Claude, the other feature that's easy to integrate. I mean, you could integrate any model provider that you want, but Claude and Codex are the two that are readily available when you try to install the stuff. You could put in another API for like Gemini and stuff, but with Claude, Claude generally tends to be a lot more verbose. So it will give you a lot more information from my understanding. I haven't tried this for myself, But when you integrate Claude Code with Xcode, you generally find that it gives you a lot more information, which is a good thing and a bad thing. Because if you're just trying to solve a particular problem, you kind of want to cut to the chase, especially in this window. You don't want to be reading essays and a whole dissertation on stuff. You kind of want to zone in on the problem that you're having or the thing that you're investigating and get right to the point, right? So, Claude will go on and on about, the world and everything in it, whereas Codex is more just direct to the point. And this is the problem we're having here where, I'm asking it about, the Schlick function, and it's very direct and concise, which is cool, but I need more information about it. Anyway, that's it for this video, guys. I don't really have much more. I am going to investigate this stuff a little bit more because I do want to understand how fog works in a scene. As you can imagine, this is probably a very important feature in computer graphics in general, right? Just for fun, we could mess around with, I have everything back to default. We could mess around with the absorption coefficient. So let's just mess around with the absorption coefficient just to see what happens with that. And then we'll mess around with the scattering coefficient also. So this is this. Yeah. So that's the absorption coefficient. When we change it, can we do a negative absorption coefficient? So what if I do negative? Is that gonna hurt anything? Let's see. Ooh. All right, so that's what we get for a negative value. This guy is just, it's probably just going to increase the fog, kind of like what exponential thing did. All right, well, let's just make sure we're back to baseline first of all. All right, we're back to baseline. And then this is going to probably just increase it a little bit more. But it's just a plus, so it's not, it's not going to do much. Yeah, it's just going to increase the fog, okay? All right, one other thing is that if we do G to like 1.3, so this is baseline, right? With the slick phase stuff. Right, and this is when we go to like 9. Okay. Right, so this is when we go to 9. And then when we go to like 1.9, we get another weird behavior. Okay. And we get all of this. And that's your homework for today. You guys got to figure out why this happens. Basically, it's once we go over a 1, we start getting this stuff. Like if we do 3, we're gonna get even more. We're gonna get even more stuff, okay? Yeah. Okay. But that's that. Make sure I'm back at baseline. This is Cuda Education, guys. If you guys want to be able to run this stuff on your computer, basically this is Meadow 4. You have to be able to run Meadow 4 on your machine, which means Apple Silicon. I have a link to the project file below. Basically, you download Xcode, which is your developer GUI, and you download the project, you double click it, and it's supposed to run. You might have to do like a little setting thing where you sign into local environment or run, because it defaults to like remote or something, but you basically want to develop locally. So there's like one setting to do that, and then you could run it and all that stuff. This is Cuda Education, guys. Do me a favor. What needs to be done to get my channel, popular and widely distributed? Like, subscribe. You know the deal. You guys know more about that stuff than I do. But yeah, guys, we are investigating metal, and our goal is to be in a better place in terms of understanding how metal works in computer graphics in general, but how metal works in 2026, sorry. By the end of the year, we want to be in a better position. So, I know I'm focusing on a specific feature that's not necessarily even metal related, but it is computer graphics related, because we're going to have to learn how to do, fog in computer graphics, right? So this is what it is. But I am going to continue on our path of more the metal stuff, okay? But this is part of the scattering function, and we are in the shaders scatter volume file. And yeah, don't even know what this is. This is automatically commented out, but we'll have to investigate that. I'm not going to dive too much more into the Schlick phase stuff. Again, I kind of want to get back to just core metal things, but we do have a lot of things to investigate with this application. So we kind of focused a lot on the math today, but that's all right. Thank you guys for watching. Have a great day.